general, this will be a little bit of a, call it a speed dating for Vertex AI, which really is our stack for machine learning. So I start with, in general, who's the audience, right? So who makes up a data science team? And I think as viewers, you can see which bucket you fall into, right? So typical data engineers, data scientists. ML ops engineer is a newer term, and a lot of companies do not have that. So keep that in mind. This is an evolving space, and I'll talk to that somewhat. Typical developers, that hasn't changed, in business analysts, right? So these are your typical spots. So what is Vertex AI? It's an offering from Google, GCP, Google Cloud product, right? So, and I like to look at it as a stack. The bottom stack is fairly simplistic. As you move up the stack, it gets more and more complex, and different profiles basically fit into that. So what I'll do is I'll quickly go through each one of these sections to kind of give you a holistic view of what Vertex AI is, starting at the bottom. Typically, the application developers are more at the bottom, and the data scientists and the ML engineers and ML ops engineers are at the top. Just a kind of a continuity piece there. So at the bottom, what's a commercial API? Well, we'll start with the Vision API. Well, Google, we've seen a lot of cats. So if you had a database of animals and cats, you could simply run that through a Vision API, and it would spit out what the cat is, right? We know it's a cat, it's a mammal, and you kind of go down. Well, this happens to actually be my cat. I took a picture of my cat, and his name is Rascal. And Rascal, I didn't know, was a Neblong. And a Neblong has specific dietary needs, etc. I didn't quite know that. And if you're a company and you run through, you might have different types of vision requests, but you get insights into that. And you can actually have real-time turn on that. So simple, fairly straightforward, give it a picture, you get outputs, right? As you move up, so now we get to AutoML. This is sometimes a hard to understand one, but I'll try to encapsulate it. So you have a data set on the left, right? Everything starts with data sets. So say I captured my cat, and he fits into the breed on this. Ultimately, all ML is trying to do is predictions, right? So I take this data set, and in this case, I want to predict how long it might take to groom a certain type of animal. So I pass all these variables to AutoML. It breaks it down which features there are, which features have more importance, and ultimately it provides a prediction, right? So I set it up to say, give me the prediction time based on the animal, the breed, and if I'm a store, I have different stores that have functioned differently, etc. So these are just variables and features on the left. Pass to AutoML, you get predictions. And those predictions can be served. You can push those out to different locations. So that's essentially what AutoML is doing. It applies to multiple different disciplines. We have vision, we have video, translation, and tables. This is actually AutoML tables, if anyone wants to know the specifics. Okay, so continuing forward, and we'll provide this deck, Ron, to everybody. Who's it for, etc., right? I'm not going to read all the slides just because everyone can read here. But in general, this is developers. You pass in information, and you get quick insights. Not necessarily data science, but data scientists a lot of times use AutoML now to get a good baseline on their custom models. So it's a good starting place. Document AI. This space is blowing up, whether it's from AWS or us or Azure. Document AI is huge. What it means is you're actually passing it more structured documents, right? So things like driver's license, W-2s, etc. It parses the documents, right, and it returns valuable insights on that you can valid. First of all, is it a driver's license that's valid? What information on that driver's license do I want to capture? It's a refined, think of a Vision API with structure. And what it does is it returns back a confidence score on the values it gets. So say I return back the driver's license and I'm 96% sure this is correct. Well, in my provisioning process at a company, maybe I'm doing loan documents or I'm selling things with validation. If that threshold's below a certain number and I just arbitrarily took 90, I might want to have a human look at it. I might not be sure that the results are coming. This is key for customers to kind of limp into AutoML and ML in general. So They might be scared. You could put that confidence number really high so you kick back most of the documents and people still be the primary. But it's a good way to learn on the job, validate your requirements, and to move through. So the human in the middle is a very important part of things like document AI. Once again, we have different disciplines in this from Google, right? So we have lending document AI, procurement, growing space. Most customers have needs in this. So if you're one of them, you might want to take a look at it. This is just a screenshot. These are all the different parsers that are available. You essentially just pick a parser. You also can have a splitter that splits up documents into sub-parsers. This is an example of a 1040, right? So I passed it a kind of a crappy document, and the document is now providing the insight. So you look on the left-hand side, it's found the social security number from that garbled mess on the right, right? So that's essentially how document AI works. And here's where I set that threshold level, whether to kick it to a human or not. So that's pretty much document AI on the myopic side, very specific. It's moving though into knowledge graphs and content warehouses. I won't go into these because we don't have a lot of time, but think of those as contextual graphs, right? So you get input, you get things like, say that document AI was run with a driver's license, and that driver's license was from Ohio. Well, maybe you had a marketing campaign and the people coming in, you're identifying the state. You put that into a knowledge graph. Essentially, you're making contextual evaluations about the information that comes to you. You store that in a content warehouse where you can do your business analytics on the backside. Okay, so that's the nature of things like document AI. Who's it for? Once again, verticals are very big on this. Most companies, though, do have that. Unstructured data is a huge area of concern for companies. They have tons of documents. They don't know what to do with it. These tools can get value out of those unstructured documents. BigQuery ML. Those not familiar with BigQuery, it's essentially a data warehouse on GCP, right? Basically a big SQL engine. So historically, you pass it data sets and you do normal SQL queries on it. It now has the capability to do a number of machine learning algorithms directly on that data. So instead of having to move the data around, I can simply just invoke an algorithm. This is a number of them. Once again, I'm not going to read them all, but linear regression, maybe I want to classify, break down this data set from a huge number of different things into, give me some classifications, like 4 groupings of this, so I can get some, I can stratify that information. You can do that. The last one, this slide speaks for itself, just kind of talks. Essentially, you create the model with BigQuery, right? You pass it which one of these models you want to throw out the data, and then it returns back predictions. Okay, now I want to throw out some data. What kind of predictions do I get back? Fairly simplistic in its nature, but very powerful in its how you invoke it. Okay, BigQuery ML. Bunch of things under the covers. Essentially, Google is an ML first company, so we take a lot of what we learn on ML and we abstract it from the end user so that you get a lot of this, so that you don't have to learn it. You can, if you want, customize some of these values. It just takes a little more looking into the plumbing. So even though we do the abstraction, we still allow you to modify some values. Okay, who's it for? Once again, I'm not going to read them all, but it goes through. If you're a big, strong SQL shop and you have people doing data warehouse already, good way for you to get some advanced analytics out really quickly. Custom models, now we get more and more complex, right? We've moved up the pyramid. You can see we're almost at the top. Custom models are where the data science live, right? They're using things like notebooks, Python, using frameworks like TensorFlow, etc. And so these are where the data scientists have historically lived. So they get data. They build these custom models on, say, notebooks, right, with frameworks, and they then deploy a model. And that model is now ready for you to push it out somewhere, so you have to have some way to, quote, serve the model, right? So you deploy it. That means you version, say, 1 of my model. I've validated. Now I want to push it out. Maybe I push it out to mobile devices, or I push it to location internal and throw batches at it. All great, but in the historic world, this is very bespoke, right? Very one-off. There's no real governance on it. There's no real way to monitor it. So Vertex AI allows you to the data science right from the Jupyter Notebook to push the steps essentially into Vertex AI. So you know what version was deployed, you know when it was deployed, and you can gather metadata from that. So I'll quickly go through that. So data starts with the data extracts. This is very important. Where did the data come from that you're training? Without this type of framework, someone runs a model, you're not quite sure what data actually provided that. And you get data drift, you get all kinds of different problems from data scientists if you don't know the actual data, okay? So once again, in a notebook, this is actually giving you more specifics you probably have. There's a, there's a Git project I have out there that you can go into each one of these and you can actually pull in the notebook and run it. So this is showing you some of the specifics. Essentially, that just starts up an instance for your notebook. It runs, right? You bring in this this notebook itself. These are the frameworks, notebooks you can actually deploy. Right? So we go through each of these if we have more time, but might be interesting to you. It's out there, it's public, etc. Okay, this is essentially the data set I trained on, right? This is just a closer view of what that data looks like. In the custom models, which hyperparameters were used, what features were used to create this whole model. Things, if you don't have a framework, are just given to a developer, a data scientist, and you don't know what happened, right? You get the deployed model later, you don't know how it got there. Once again, this goes through how you break that down, right? So these are the experiments that were run. This is Open TensorFlow. This is where you get basically metadata about it, shows the versions, how many epochs were run, hyperparameters, etc. Then this is this is a tensor board for those that like to geek out on exactly how the model's running. We can go into all this. Essentially, this is giving you a visual of what that model actually looks like, automatically produced from basically Vertex AI. Deploying, just what it sounds like. I want to stand it out there, version it, right? So this is just how you do it, push it out, etc. Last is serving. Serving is where the key is for the last part we'll get to, which is ML ops. When you serve models in, quote, the old world, they just were deployed. You don't have a lot of insights on if they're actually staying relevant, right? When you serve it on Vertex AI, we have things like TensorFlow Extended and pipelines underneath the covers that are tracking the metrics over time, who's doing it. Is there drift happening on my model? Is my confidence score going up or down? How is it doing to my baseline? Okay, very important in modern ML development. Okay, so once again, this is the last one of the notebooks. Finally, we get to ML ops. I think I have a few minutes here. So ML ops is, like I said, a growing field. What it really is you're trying to take the concepts of CI/CD in your enterprise companies and apply them to machine learning. Historically, once again, the custom models I showed in the prior slides is kind of how that's been done. Data scientists with a notebook. They get a model, and then someone pushes it out to production. Not a lot of structure, not a lot of governance, and not a lot of monitoring, right? So if you break down what's happening in order to do a CI/CD process, I'm showing them on the left, right? You have to identify the data, choose the model, experiment, tune it. Ultimately, transform data comes in, train, serve, review. Same steps we kind of talked about in the custom, trying to take these and operationalize them. So you take those steps and you push them into an ML pipeline. That's where that metadata is being captured, right? What version, where do the models come from, the data come from, etc. You do the data validation, you do the transformation, and you evaluate. All things that are essentially from that custom one, we're now pushing into a framework and different tools, right? Feature store is growing and very important. So a feature store is essentially which features, say I'm a data scientist and I built a model and I use features X, Y, and Z. If I don't communicate that I've built these features and I've refined them to other data scientists in my group, they have to go do the same refinement on those features. If I simply put them to a feature store, they're centralized. And maybe the next data scientist doesn't have to spend as much time defining X, Y, and Z for their model. I've already done it, right? I've got them perfectly fitted for ML ops and Jupyter Notebooks. So Feature store is a very important part of MLOps. And then lastly, we have the serving, right? So you evaluate, you serve the model, you gather the metadata from the served models into this so that you can rinse and repeat. That's MLOps in a nutshell, and something that you probably need to look at closer if you're in the MLOps and data world. And the way this looks like under the covers, for those that are interested, so Vertex AI, this is all managed for you, right? You don't have to do it. You can run a custom version of it, and under the covers, it's Kubernetes, right? Kubernetes is basically doing these things like pre-processing, training, serving, review. It's interacting with the feature store, it's interacting with the container registry, and your data sets. So underneath the covers of managed pipelines on Vertex AI is simply Kubeflow, right? Kubernetes with TensorFlow, but we don't limit it to just TensorFlow, even though the name says Kubeflow. We support other frameworks as well. So you don't have to use TensorFlow at all. You get a little more of like all the features, but if you're using other frameworks, we can accommodate no problem. Okay, so I believe that is it. Just lastly, who's it for? And that's it.